Hello children. So in this section we will start with megasporogenesis or development of a female gametophyte. This is an important what you call section, and just focus on what I am telling you. In the same way, like microspore development was there, and they started with the archisporial initials. Archisporial initials, they are, that is primordia, they are called as primordia. So this also, the ovule, in the ovule also there is primordia from which the megaspore is going to develop. Archisporial initials again undergo the periclinal division. I told you earlier that periclinal division is like this, right? That means they form two rows. In here also the archisporial initials undergo this type of mitosis, that is a periclinal division in the initials, and they form two rows, one cell each. Very important, listen to it very carefully now. This is the outer one is called as primary parietal cell, and the inner one is called as primary sporogenous cell. This parietal cell, the primary parietal cell, sometime it goes into one more division and then it degenerates. These are the cells which are formed by the primary parietal cells and they degenerate by giving their nutrition to the sporogenous, the primary sporogenous cell. Immediately when these degenerate, what happens is this: the primary sporogenous cell, it becomes bigger in size and itself it starts behaving like as a megaspore mother cell. Megaspore mother cell is the cell from which the megaspore is to be given a rise. Megaspore mother cell, short form MMC, we know that it is a meiocyte and that is diploid. Meiocyte is what? In which the meiosis has to occur. This is called as megaspore mother cell. Repeat. Till this, what we have done is a single cell was there called as archisporulation. It undergoes periclinal division. Outer layer is formed and the inner one is formed. Only one is formed here. Just listen to me very carefully here. Only one is formed. The one primary parietal cell and the inner one is called as primary sporogenous cell. The parietal cell, it can give rise to another two cells or even not, but it degenerates by giving it nutrition to the one of the, that is primary sporogenous cell. This cell becomes big, becomes larger in size, and it starts behaving as a megaspore mother cell. That means it is a meiocyte now, which will give rise to the megaspore. Next step. This megaspore mother cell, we know, will undergo meiosis. And we know when it will undergo meiosis, it will give rise to the 1, 2, 3, 4. 4 megaspores which are all haploid now, because this is a resultant of a meiosis. Is that very clear? Now next. This megaspores, how many megaspores are formed here? 4. Out of this 4, these 3 will remain as it is and the सबसे lowest वाला, that means the lowermost at the chelazal end, will become functional. This becomes functional. This becomes bigger in size and this becomes functional megaspore. At every step, I have written the micropyle and chelazal end. Micropyle and chelazal end. Micropyle and chelazal end. Micropyle and chelazal end. Here what we have to remember. The chelazal end microspore becomes functional and the micropyle end degenerate. Again, they degenerate. These degenerate. Again, giving its nutrition to the growing megaspore, the functional megaspore. In microspore formation, when pollen grains were formed, when microspores were formed, from the 1 mmC, that is the microspore mother cell, we got 4 microspores. But here in this case, after meiosis, we have got 4. But the 3 at the micropylar end, they degenerated and only 1 microspore remains functional. It becomes functional here. Now, in the next step, this is called as megaspore. This megaspore will further develop into a embryo sac. Okay, this megaspore, what happens now in this is, this has 1 nucleus. All the 3 here degenerated. 1 nucleus is there. Now, it will start mitotic division. But what will happen here is, the cell undergoes karyokinesis, which is not followed by the cell formation, that is the cytokinesis. Here, the first karyokinesis occurs. Right? So, when the first karyokinesis occurs, we get 2 nucleus from the 1 nucleus, because mitotic division is there. The ploidy remains same. What is the ploidy of this megaspore? We know N. So, when it has undergo mitotic division, this is also N, this is also N. Both are haploid, what you call nucleus. Then, it is not followed by karyokinesis. Then, it undergoes second karyokinesis. After karyokinesis, second karyokinesis, from 2 we get 4. You know, they are at the extremes. Then, the third karyokinesis occurs. We get 4 at each side. Means these 4 nucleus will form 8 nucleus. Third karyokinesis. Repeat. From a single megaspore, which is haploid, it undergoes 3 times karyokinesis. From 1 nucleus, for the first is formed 2, then from 2 nucleus 4, then 4, from the 4 nucleus we get 8 nucleus. This stage is called as 8 nucleated stage. We have got the 8 nucleus at the extremes, at the ends. That means 4 at the micropylar end and 4 at the chelazal end. We all know that at the micropyle end, we have egg apparatus. That means 1 egg and 2 synergids. And at the chelazal end, at the other end, we have antipodals. So what happens in the next step? Here the what you call cytokinesis occurs. That means the cell wall formation occurs. After 3 karyokinesis, which are not followed by cytokinesis, after this stage, cytokinesis will occur. In this, what will happen? The upper 3 nucleus will form the egg apparatus. The lower 3 nucleus will form antipodals, and 1 from each micropyle end and the chelazal end. These 2 nucleus come in the center. These 2 forms polar nuclei. And this cell becomes central cell, because now the cytokinesis has occurs and therefore we have got the cell walls now. This is called as synergid. This is called as egg. And stages can unite together to form a secondary nucleus. Now we all know this is the resultant of mitosis. Therefore, all these nucleus will be haploid. Apart from the secondary nucleus which will be diploid. Why? Because these haploid, both polar nuclei haploid, they join together to form the secondary nucleus which will form diploid structure. Rest, the egg is haploid, synergid haploid. This another synergid is also haploid structure. These all antipodals are haploid. Now today we have noticed, we have known now that how these cells are haploid because they have undergone mitosis after the meiosis division. This structure is called as embryo sac and the stage is called as 7-celled 8-nucleated stage. How come? Let us count it. Let us count the nucleus first. That they are 8 or not? 1, 2, 3, 4, 5, 6, 7 and 8. Okay. How it is 7-celled? 1 cell, 2 cell, 3 cell, 4, 5, 6 and this whole cell is called as a central cell. This is a 7th cell. Therefore, 7-celled 8-nucleated stage. So, this is how the embryo sac is formed. Once again, I want to recap the things. What happens? The archisporial initial undergoes periclinal division. It forms the outer parietal cell and the inner sporogenous cell. The outer parietal cell degenerates. Only the inner primary sporogenous cell becomes large in size and it behaves as a MMC. That is the megaspore mother cell. This undergoes meiosis. When it undergoes meiosis, it forms 4 megaspores, out of which the one of the megaspore which is at the chalazal end becomes functional. Rest of the 3 megaspores at the micropylar end, they degenerate. One of the functional megaspore, which is a haploid structure, will undergo consecutively 3 mitotic divisions, only karyokinesis, not followed by cytokinesis, and therefore from the one nucleus, first 2, then 4 and then 8 nucleus are formed, which are all haploid structures because mitosis has occurred. From this structure, cytokinesis occurs, the cell walls formation takes place and we get an embryo sac. We have to remember at the micropylar end, we get the egg apparatus. This portion is called as egg apparatus. I am repeating again and again, including 2 synergid and 1 egg. We get 2 polar nuclei which later on forms the secondary nucleus. As they both unite, this becomes diploid and 3 antipodals all are haploid. Therefore, this stage is also called as 7-celled 8-nucleated stage. That's all for the megasporogenesis. Thank you.